So my name is Hongzhu. This is Jordan, representing Aegis. So name come from the Greek mythology. The Aegis is like the shield of Athena and also Zeus. That's also Athena, if you ever watched Saint Seiya. Yeah, so I'm a student at Tufts, and many of our professors work on robotics. They're currently thinking about world model, especially in the context of physical AI. And the core question here is simple, can an agent build an internal of the world, predict consequences, and generalize beyond what it has seen? So in robotics, we worry about generalization, sim-to-real gaps, and also distribution shifts. And when I think about that, I realize something. A competitive game like Dota 2, it's basically a structured environment, and with delayed rewards, strategic decisions, and also massive locked data. And I'm also a mobile player. I often wonder whether my teammates are actually real human or just badly trained agents. So the real question becomes, can we turn the structured Dota 2 match logs into a proactive decision system? And it's not about predicting who wins, but answering if we buy this item now, what happens? And if we ward now, what changes? And also, if we skip the fight, we don't fight, what's the impact? And we focus on a purely structured offline evaluation system. We have no plugin for a vision model or in-game access yet. So everything is just reproducible planning from the logs. So we use about 30,000 parsed open Dota matches. We train on the older patches and test a zero-shot on the latest patch. And from the raw JSON, we reconstruct a unified event timeline and also per minute team states. We track the advantage curve, item ownership, vision activity, skirmish. They call it team fight. Basically, it's a team fight signal. And also at each minute, we define a structured state, include the goal and also experience advantage, which key items are owned, recent kills and also team fights, and the vision activity, the ward activity. And everything structured and fully reproducible. And we split the system into two components. First, it's basically the policy, it's the proposal. The proposer will predict the next item distribution over many classes of equipment possible. And this is essentially behavior cloning. What strong players tend to buy in similar states. If you're like a top performer like Faker, what Faker is gonna do, basically. The Faker is from League of Legends. So this is essentially behavior cloning. And what's strong, and second, we also have the value model. We can treat this as an Oracle AI, basically. The value model is going to predict the win probability over the short horizon future advantage changes. So this is basically together they are the counterfactual evaluator. We have the policy that proposes and also the value function that evaluates. Then we combine them. The policy will give the top tier candidates. We then filter infeasible action based on the cost and timing. You can't just buy anything you want. There's always, how much gold you have right now. We have to filter out the infeasible actions. Then we have the value model that scores each candidate. Then we choose basically the thing that gives you the max payout. And so this moves us from imitation learning to the value-based plan. And this is basically the core agent-like component together. And we have, so far in the experiment today, we have 3 core findings. The first, the value model improves significantly. We have a baseline that only looks at the experience curve and also the gold curve. That's the baseline. And when you look at more stuff, basically where the team fights happening, where the team is placing the war, and many stuff, we can actually improve the model. So an improved model over baseline has better AUCs, basically the accuracy, and also it has the standard error. It's decreasing. So basically the key idea here is if you add item ownership, also add vision, add team fight signal, these features actually predict better short horizon prediction rather than just looking at gold. And second, we have the policy that's has a very good recall. So it's like about 88%. It basically means that the true next item in the candidate set almost we hit that 90% of the time. So we're predicting it accurately. So this is exactly what we need for planning. And third, we have the generate and score that produce the opposite positive uplift. So it's within all the feasibility constraints. The average uplift versus baseline is about improved, and under the realistic constraint, the value-based selection improves selection expected outcome. So this is all zero shot on a new patch, so it didn't really drift. a transfer between patches. So right now, what we've done so far is what we call phase one. We basically answer a single question. It's like what item, what equipment you should buy. And moving on, we were thinking also to do where to act, basically. So like, the map is so big, where do you place the vision? If you don't see your enemy, you're probably going to be surprised, when in the team fights. But the next one is gonna give you a better decision on where should you play the dwarf, basically. And we're also planning adding fight participation decisions, extending the short horizon plan tokens into a long term to move from single step to multi-step planning. Also, I guess just for illustrative purposes, this is some white coding stuff from Gemini, right? Gemini. So it's like in real time, and the game is happening. You have the AI that produce the value model. Basically, like, are you winning or are you not winning? And for each player, what's the best thing to do? What's the best item to buy? And so it gives you, as we said, it's gonna hit 9 out of 10 times. So it's pretty solid. Then if you're interested in a technical report, is also on my GitHub. You can read about the formulation. The benchmark data sets there. You can directly run it yourself. We also have another word model idea from Jordan. Well,
so I thought Dota would be too complicated. There's too many parameters and too many things. So you need too much data in order to process it. So it's like unfeasible. So I picked an easier game like Street Fighter. But then when I try to get the data for this, it doesn't exist. There's like stream replays, but you need to parse all the actions out. So I just running like 2 of these simulations, or it's not simulations, these are pro matches. I'm trying to do like imitation learning, and it's running like 10x speed. I'll get like 10,000 replays in 2 days, and then I can redo this thing, and we'll see if we can make like a pro Street Fighter bot. And then like from them playing it, you can like apply it to world model and see if it can interact with this kind of. And that's what I did.